Welcome back to the last episode of our Chop Anatomy workshop. It's been a great ride. If you haven't checked out the previous episodes, please do. There's a lot of important information that is hard to find. I put a lot of effort into researching and recording and editing this series, so I hope you subscribe, follow, or check out my Patreon. There's a lot of stuff there. And without further ado, let's graduate. In the next part of our Chop Anatomy workshop, we're going to take a look at a few interesting examples, issues you might have faced. For example, the next one, so let's assume this scenario that you created some nice visuals, hopefully nicer than these, and you mapped some controls to your MIDI controller. That is all fine, but the next time you start the designer, the MIDI in is actually going to be reset. So all your channels are gone and suddenly your visuals are also gone and you do have a lot of errors and now you have to fix these. Well, yeah, sure, you can just move these, but that's not a nice solution. There should be a nicer solution because also, for whatever reason, there could be also other scenarios when something like that happens. So it's good to know how we can deal with the situation when channels kind of just disappear. Before looking at the solution, we will make a small detour and take a look at this rename here. And even a detour of the detour, that although what you will see is kind of a common way to deal with MIDI in Touch Designer, it's not the best way. And I will dedicate a separate video on that, but let's go on. So my goal here is that I don't want to tie these radiuses to the MIDI control, the MIDI channel, and the MIDI control index, because maybe I want to change it later on, and I don't want to change these expressions or these references. So for that reason, we just rename our MIDI channels right after the MIDI in to fader 1, 2, 3, 4. And the way that I'm doing this here is I'm taking all the channels and then I'm renaming it to fader 1 and question mark. If I just did fader like this, it wouldn't work. It would only rename the first one. If I did fader asterisk, then it would put also this after the fader, so that's also no good. Of course, you could type out all of them one by one, or type out fader 1, 2, 4. That also works. But the more elegant solution is fader 1 question mark. And why this works, I actually have no idea. And I cannot even find it in the documentation to reference it to, like I really looked. In any case, there's 3 pages of documentation you should look at. It's pattern matching, pattern expansion, and pattern replacement, which are all very important for chops. This is your homework, I guess. So yeah, fader 1 question mark, it just works. This is nicer because if we have more faders added, then we don't need to update what we would have had before. Is like fader 1 to 4, and then I added more faders and suddenly those are not working. So the fader 1 question mark is a more universal approach. And also what's kind of important here is depending on the order of these channels, before I had actually this control 21 as fader 1, but because I moved my control 17 first, suddenly that became now fader 1, and that's now controlling my circle. So it's good to then also change the from and say that we want the channel whatever control 21 to 24. So that is gonna make sure that my 21 is going to be going to the fader. Just a little side note. As I said before, this is actually not the recommended way to deal with MIDI mapping and MIDI channels. There will be a separate video about that. But since this is a common approach, I thought I would cover this anyway. Now finally, let's take a look at the solution, how we can deal with losing chop channels in this MIDI example. So again, if I lose these channels, I have all these errors, right? There are actually multiple levels of solution to this. And the final solution is going to be this component that I created, where also there's going to be a pickup. So it's only going to take the live input that I'm moving here once it reaches a certain value that we saved. So this is going to make sure of the smoothest recovery from these lost channels. And this will also work when you restart your project and so on. So this is going to be on my Patreon. I'm going to do a breakdown of it also here. But yeah, if you like my content, please consider joining my Patreon or just subscribing here. That also helps a lot. But let's see the first solution. So I would like to introduce to you Feedback Chop. I'm sure you've used Feedback Top. What about feedback chop and what can we use it for? I actually use this chop quite a lot for multiple reasons. We will have a look at some of those reasons. But the first one, what the feedback chop does for us, it introduces one frame delay, but it holds the channels. So if I had all these fader channels in there and my MIDI was reset, it keeps those channels and I don't have an error here. What happens next is when I move my MIDI controller, then actually only the latest one updates. So that's still not perfect, but at least it holds values after a project restart also, which is great. There's also a second input to this feedback chop, and it's called initial conditions. And that's going to allow us to define the starting values when we restart the project. An easy way to define these initial conditions is with a constant chop. I give the constant chop a lot of shit, but it has this very cool feature called snapshot input. Then this now took a snapshot of my input. I can feed this into here. I move my MIDI, the constant stays. Let's simulate the project restart. So I'm gonna reset my channels here and I'm also gonna reset. And now it's snapped to these initial channels. Still, we have this problem that when I move now my MIDI, it still gives me an error because as soon as this feedback input cooks, it's gonna update with the current channels. So how can we solve this? And so the next step is making sure that we have these 4 channels always present in our chop chain. And to do that, we can actually ditch the feedback. It's been great having you. We learned some things about the feedback. It will come back soon, though, with another use case where it will also stay. But let's get rid of this for now, and let's add a replace chop after this constant, which holds now our initial values and our channel set. And let's connect our MIDI input to the second input. So now by default, this constant one is there. And when I move my MIDI, it's gonna jump there. So let's do that again. Let's reset the channels so that this is now how our project starts. And now when I move my MIDI, it's gonna jump to the latest value. And as I promised, here's the breakdown of this pickup solution, which is the best one I could find. So as you can see, I had my MIDI channels lost, but I saved a snapshot. And as I'm moving my MIDI fader around, when my MIDI fader reaches the same value that the snapshot was, it picks up from there, thus preventing any kind of a jump in the process. And actually to achieve this, we only need one more operator, that is the bind chop. The bind chop, it has a channel pickup option if we turn that on, and then we reset our channels. Thanks to our replace and the constant, it holds the channels. And the next time I move my fader, you can see that it's gonna pick up at 0 actually. So if I move my fader down to 0, it's now picked up and now it's following my input. And I can do the same with the other faders. So one bind chop with the channel pickup has solved this. I actually happened to first build out this functionality myself because I didn't know that the bind chop could do this. One of my patrons let me know. So here's a quick breakdown how you would do that if you didn't know that the bind chop could do this. We start with the constant to hold the snapshot of the pickup values. And then immediately what we do is compare the current values, the input to the snapshot with the math. So we subtract these 2 operators. And then basically when this reaches 0, it means that we have reached the pickup value. And when we do that, we have an express chop here that goes to 1 if the input value is 0, basically. And then I use the hold chop to basically hold that value indefinitely. As you can see here, I use the off to on, and then I actually connected to both inputs this expression. So now when the pickup value has been reached, this will stay at 1. And then this next hold makes sure that we take over after the pickup value has been reached. So I'm using here a while on sampling. So while the second input's corresponding channel is 1, it will take the input. As you can see up here, it takes this live input now. But for the last two channels, which have not been activated yet, it doesn't actually take those values down here. As soon as I reach the pickup value, which should be somewhere here, then it takes that live input. Still, my fader 3 is not live, as you can see here. As soon as we reach the expression here, then we have the live input going on. Instead of the expression, I could have used a logic chop here, and instead of the hold, I could have used a count chop as well, but that's beside the point. But of course with the bind, now it's a super neat and nice solution, and now we have it packaged up in this component. This is, by the way, usable not only for MIDI input, this can be useful in general. In the next example, we have a circle that we want to animate, and we want it to grow for a certain amount of time, stay at its maximum size for an amount of time, then shrink again, stay there, and then grow again. There are many ways to solve this issue. One of them would be building the animation out of a multi-sample chop with different patterns and then joining them and then doing a lookup. I wouldn't like this option because it's just going to be a mess to change the timing. Like if I want it to be held for exactly 0.33 seconds, then I would need to find out what the length of this pattern should be. Then also the total sample size of this animation would change, and then my lookup would not work anymore as I expected. Another option would be to actually animate this with keyframes, but then again, changing that and keeping the timing accurate is kind of a pain in the ass, so I also wouldn't do that. You would think you could also use an LFO with a square wave and then put a filter after it for the smoothing of the animation, which could be okay, but again, I have to play with the bias to change the timing, and then again, it's not enough control. So here we're going to take a look at my preferred option, which gives us the most convenient and accurate control of this animation. So let's imagine the scenario that you're working on some visuals and maybe this circle is driving a particle system or whatever, but you want to pause the growth of this circle. You don't want it to pulsate all the time. So essentially what you want to do is once it reaches its full size or 0, you want it to actually pause this LFO. First of all, we need a trigger when this LFO reaches 0 or when it reaches its maximum. For that, I'm going to use an expression chop once again. It's a very useful chop because I can just write a very, very simple Python expression here that says that this channel output should be 1 if me.inputVal. So me.inputVal will always refer to the input value as the name suggests. So if me.inputVal equals 1 or me.inputVal equals 0, else give me a 0. And this is why Python is really cool, because we could write this out in a very natural sounding language. And we can already see this working. It's giving us a trigger. We can observe something pretty interesting here. When I change the frequency of this LFO, we can observe that actually this expression is not triggering somehow anymore. And that is because we actually never reach 1 or 0 exactly. And this is looking at 1 or 0 exactly. In general, when dealing with floating point arithmetics, such as we are doing now, it is never a good idea to compare exact numbers, because the way floating point numbers work don't really facilitate that. And so the best course of action that we can do for now is use a logic chop. And the logic chop has this option of off when outside bounds. And here we would input some very low number and some number that's very close to 1, such as these numbers. Now we can see that we are getting these triggers. We just need to invert this, and in the channel pre-OP we can put an invert, and that will give us those triggers. As a reminder, what we're trying to do here is whenever this LFO reaches 0 or 1, we want to pause the play of this LFO. So now we have the trigger, and now we need a timer because we want to say I want to pause this for X amount of seconds. So let's put down a timer, and the second input of the timer is actually a start trigger. I'm going to put this to a length of 1 second and then connect this here. So we'll see that the timer starts and finishes in 1 second. So what we need from here is one of these channels that we can use to drive this play toggle. And for example, the running or the done would be one of those. let's use the done. I'm gonna put down a null. And then if I use this done here to reference back to my play toggle, we get a little triangle here. I will talk about that in a second. But what we see now is that once it reaches its full size, it stays there for 1 second. Let's increase this also to like 3 seconds to see it more. Now, as it's growing, it reaches its full size, stays there for 3 seconds, and then goes down again. And then when it reaches 0 size, or close to 0, it stays there for 3 seconds. Okay, so that's kind of the solution, right? Because now I can freely change how long the circle stays at its maximum or minimum size. And I can also change how fast it grows or shrinks with the frequency. But we're not done yet. Let's take a look at this triangle here. It says warning, cook dependency loop detected. And that is right, because by referencing back to this LFO, which, this null, the results of this null come from this LFO. So we are creating a loop of signal. It's giving us this warning. Right now, it's not giving us any issues, but there could be scenarios where it's actually giving us issues and we might not even foresee that. So it's best to always get rid of these cook dependency loops. The easiest way with chops that I've found is to use a feedback chop. As I said, this will have a comeback. And as soon as we have this feedback chop here, this warning is gone. And that is thanks to this 1 frame delay that the feedback chop imposes. As always, it's good to test our chop network under load. So let's turn on the hog chop and let's see if it works. Already we can see that it's not really working. That is because the timer simply doesn't catch this logic chop's 1 state when losing those frames. But as we learned in episode 2, if you haven't watched that, please go back to that episode because it's the most important one. And thanks to time slicing and some tricks we learned there, using an analyze chop after the logic and setting it to maximum magically solves our issue. And it makes sure that our logic is always caught by this timer 1. We can also see, due to some time slicing anomalies, that we have multiple samples show up sometimes here. We can solve that with a trim chop, for example, before the feedback and setting it to absolute, and that will get rid of that anomaly. But actually in this case, it didn't really matter. But I would argue it's still good to get rid of these weirdnesses, in my opinion. All right, in this next section, we're going to take a look at some underrated chop operators that we should be using more, and some functionalities that you might not know of. A lot of these examples will come from the operator snippets. I'm just highlighting them. But if you go to any operator and right-click on it and go to operator snippets, it will take you to this window. And then you can check most, if not all, chops, what they do. And they all have some nice demonstrations, multiple ones even. So I really suggest doing this for all operators and doing this actually regularly. I still, after almost 5 years of using this software, I sometimes find myself just browsing through and refreshing my memory. So let's get started with a simple one. I want to talk about selects and joins and all that. A lot of chops and also tops and also sops that do similar actions like the join and the select give the option of not connecting them via their connectors, but using an expression here, which just grabs every constant chop here, similarly to how the select works. Next up, we talked a lot about the expression chop before, and I just want to emphasize how useful it is if you want to create a toggle which goes to 1 when its input goes above a certain value, so kind of like comparisons and easy logic. I would suggest using the expression chop and getting familiar with basic Python. Similarly to this example, which says, okay, if this button is pressed for more than 0.5 seconds, I want a toggle. And we have an expression here which might look intimidating at first, but it's really simple. It checks at the input value and it compares it to the speed's maximum parameter, so par.max, which is here 0.5. The next one I want to talk about is the event chop. I think this is a real underdog that we all should be using more. The way it works is anytime the input is triggered, it creates a new sample in this event chop. And that sample has a lifetime and animation based on this ADSR curve that you can define here. So this can be great to drive with audio activity, for example. In this visual, I just used it with an LFO pulse to generate my instances and basically use this ADSR curve to offset them in the Z axis. The next one I'd like to highlight is the fan chop. For example, here's 4 buttons, and with the fan chop we can control this switch based on whichever we clicked last. So this is when we fan in. So it basically takes multiple channels of input and converts it down to one channel. But it can also fan out. So it can also create multiple channels from one channel input based on the value. So here it goes from 0 to 8, and that creates this animation here. The next one I would like to highlight is a gesture chop. For example, here I have my MIDI slider, and as I start moving it, it starts recording my gestures. So I just recorded that, went back to 0, and that stopped the recording, and it's now playing back automatically. I can change the speed here, for example, slow it down, and there's even a blending region when it restarts. This could be really useful for building some on-the-fly manual audio activity tool. How I set up the logic here currently is whenever my slider goes above 0, it activates the gesture, and then when it goes back to 0, it stops and it starts replaying. You could do something similar with the record chop, by the way, also, and an extend, and then using a speed to look up one sample from this multi-sample recording. We have used the filter chop a bunch, but there are some other options inside the filter chop. For example, the €1 filter is a super useful filter when it comes to interactivity. Here I'm dragging my mouse, you can see the actual current position as a red circle. Around it we have a yellow one, which is a normal default Gaussian filter, which is the default setting, and then the green one is the €1 filter, which gets rid of all these little jitters that we can see happening added by this extra noise also. And it actually doesn't really lag behind. The Gaussian filter, the yellow one, you can see it lags a lot. And the green one gets rid of all the micro jitters, and we get some smooth and nice and quick filter action. So the €1 filter shouldn't be slapped on. I briefly would like to talk about the slope chop. The slope chop is a derivative chop, basically taking the difference between 2 frames. Here we can see it in action. As I move, it generates some values for me, depending on which way I'm moving and how fast I'm moving also. It's a bit hard to see on the slope chop itself. If we put a filter after it, we can see what's happening. I'm gonna move the slider left slowly. It gives us a negative value. And then if I move it quicker, it gives us a bigger value. It's also pretty easy to recreate the slope chop. We just take the current value, we take the previous frame's value with a feedback chop, and then subtract those 2 chops, and we essentially get the same thing as you can see it here on this trail. Next, I'd like to highlight the spring chop. Here it is the green circles animation that's driven by the spring chop. It's a spring's physical model that runs in the spring chop. We can also see it in the trail settling down in a spring motion. It can be a little bit difficult to get the hang of the parameters of the spring chop, but it's also fun to play around and try to find some cool motions. Here's a fun page that you will find on my Patreon using the spring chop. This is, by the way, not using any feedback. There's some other techniques used here, so do check it out. It can produce some really funky movement, as you can see here. Next up, a hidden functionality we've all looked for, which is reversing a chop. It's hidden under the stretch chop, so here you can reverse the interval. And if you have difficulty finding this with my free toolkit that you can get from my GitHub, I have custom search words that you can also edit yourself, so whenever I type reverse, stretch highlights here for me. Next up, I'd like to talk about the trail chop a little bit more. It can be used in many scenarios rather than just monitoring. For example, we can use it to normalize our audio activity. A lot of times you run into an issue when working with audio activity that the audio levels change between songs or between instruments, and then suddenly your fine-tuned visuals just are out of control. So it's always a good idea to normalize your values between 0 and 1. And with the trail chop, we can do that with the audio activity. So here we have the audio coming in, we analyze the RMS, so basically the volume, let's say, and we can trail that. Here we can see its range, but then we put an analyze after it. So we analyze this trail and look at the maximum value. And if we divide the maximum value with the current value, we basically get the normalized value between 0 and 1. Here we can visualize that, and here we can see that this nicely conforms our audio between 0 and 1. And if I change to different song here, even though they are at different levels, my audio activity will stay between 0 and 1. So in this case, we use the trail chop for windowed averaging or windowed normalize function. And this window length will dictate how quickly we adjust to volume changes on our input. I suggest looking into the object chop. It's a very, very useful chop with a lot of different functions. It can calculate distance, it can calculate orientation between different objects, and a lot of other things as well. So do check out the object in the OP snippets. And last but not least, the warp chop, which is a very funky chop. It can basically quicken or slow down time. So here's our input, this sawtooth. And if we set the second input to 1, it will result in the same chop. But if we set it to 0.5, it will slow down this chop to half speed. And then we can make this variable also, obviously. So for example, with the ramp, we can start slow and then make it play back quicker and quicker. Here I made an example where I warp a noise and then play it back as audio. So this is without the warp. It's just some noisy sound. And then using this sine warp, it makes it sound pretty cool. It's a nice one to play around with. As I promised in the beginning, I will show you some of my exclusive chop tools as a replacement of other chops. So for example, I really don't like the constant chop, as I've said many times. It has some good qualities, but those good qualities can be also made into bass comps that can be more useful. For example, this constant chop, which is not really a constant chop, it's a constant bass comp, can be made into any parameter type. So normally a constant chop would be constrained to using only float sliders, such as this. But here we can also change it to having only ints as such. We can even have it as a bunch of menus or a bunch of string constants. And then the output we would use is obviously the dat output. So I would say this is a general constant bass that I like to use. And it also solves one of my biggest gripes with the constant chop, that whenever you want to refer to this parameter object here, const 0 value, it is just that. It's not really descriptive. It doesn't really tell me here where this is coming from, like what is this supposed to be. It's just kind of a nameless parameter, const 0 value. Well, maybe it would be nicer to refer to it as amp. Generally, custom parameters are a nice solution, but even with this constant base, we have the issue that these are not named. Except I did some Python magic where I can refer to this foo channel, for example, as op constant 1. So now it's this constant that I'm referring to, dot foo with big F in this case. So now it's linked to this parameter. And now when I look at this expression, I know exactly where this is coming from and what it's supposed to be controlled from. I find this to be much more verbose and understandable than what we had before with the constant. The next one is this chop process base comp, which includes my most used chop operations. So that would be a limit, so I can quickly make a value loop between ranges, or as a matter of fact, a simple rearrange. Also an exponent value, I use exponents a lot, between 0 and 1 always. It also has a built-in lag, so I can very easily lag values. And then there's a speed toggle, so right after these operations I can put a speed and also have the common speed operations here. I can also use this as a constant chop replacement, so I can define the value here, and then that would be taken as the input. And finally, the chop bank, which is the ultimate chop base comp that I could come up with. It combines the previous two into one sequential parameter block bank. So here I can do a lot of things just from this one base comp. So I can create new channels, I can set their values, I can do operations on them, I can set them also to the speed, or give them a lag. Individually for each parameter block here, which are the separate channels, it has some fancy functionalities too. So for example, if I remove this foo channel from here, it will take the input channel in this case. And then also I can pre-gain it, so I can attenuate the input. And there's also a post gain. And these are just a few examples of some utility that you will find on my Patreon, as well as a lot of visual stuff and a lot of tips and tricks. So be sure to check out my Patreon. And with that, I hope you enjoyed this workshop series. I put a lot of energy and effort into this to research and give you the best information that I could find. So I really hope that you appreciate it with a subscribe, a like, a comment, or a Patreon follow. And I hope to see you around.